नमस्ते दोस्तों, स्मार्ट माइंड्स ट्यूटोरियल्स में आपका स्वागत है। आइए आज कुछ नया सीखें।
So let us cover this question. This is very important from second unit of statistics probability distributions. So the question is, prove that binomial distribution is the limiting case of hypergeometric distribution by stating the conditions. So in this first you need to write the hypergeometric distribution introduction and then you should start this. Hypergeometric distribution tends to binomial distribution. So the binomial distribution is said to be the limiting case of hypergeometric distribution under the following conditions. What are the conditions? Number 1, n tends to infinity. Number 2, m by n tends to p and small n by capital N is ignored. These are the two conditions. So first let us write the formula for hypergeometric distribution. So the hypergeometric distribution is defined as P of x is equal to x equals to mx n minus m cn minus x by ncn. So whenever I say like this mx, what do you mean? That means mcx. That means out of m items, you are selecting x items. Okay. So now that is equal to, now let us apply NCR formula. What is NCR formula? N factorial by n minus r factorial into r factorial. Now for this, we will apply the formulas. So m factorial by m minus x factorial into x factorial. And how can I write the second part? N minus m factorial by n minus m minus n plus x. I am subtracting both of them. Factorial into n minus x factorial. Okay. So that is equal to m factorial. Here what can I cancel? M factorial by m minus x factorial into x factorial into, now see, n minus m factorial. How can I write? N minus m by n minus m minus n plus x factorial into n minus x factorial into, how am I writing? N minus n factorial into n factorial by n factorial. Okay. So how we are writing this? N minus m factorial, we are writing as n minus m into n minus n factorial into n factorial by n factorial. So now you see how we are separating it. M factorial, we can write it as m into n minus 1 into m minus 2 into so on up to m minus x plus 1 into m minus x factorial. by, now m minus x factorial into x factorial we are writing as it is. Now coming to the second term. Now n minus m factorial, how can we write? N minus m factorial, n minus m into n minus m minus 1, so on up to n minus m minus n plus x plus 1 into n minus m minus n plus x factorial by n minus m minus n plus x factorial into n minus x factorial. Then there is one more term. What is that? Into, what is that term? N minus n factorial into n factorial by n into n minus 1 into n minus 2 into so on up to n minus n plus 1 into n minus n factorial. From here to here, this is only one step. Understood? We are expanding three terms here. Now that is equal to m into m minus 1 into m minus 2, so on up to, now here we can cancel m minus x factorial, m minus x factorial. Then here this factorial cancel. Then here n minus n factorial cancel. So on up to m minus x plus 1, whatever is left we are writing now, by x factorial into n minus m into n minus m minus 1, so on up to n minus m minus n plus x plus 1 by n minus x factorial into, in the third term what is left? N factorial by n into n minus 1 into n minus 2, so on up to n minus n plus 1. This is left over. Now from here to here, this is one single statement. Understood? Now how can we write this? This is equal to n factorial if I take out. What am I left over with? M by n into m minus 1 by n into m minus 2 by n, so on up to m minus x plus 1 by n into n power x. Why? Because there are x number of terms here, by x factorial into n minus x factorial into, now let us see the second term, n minus m by n into n minus m minus 1 by n, so on up to n minus m minus n plus x plus 1 by n into n power n minus x by n by n into n minus 1 by n, so on up to n minus n plus 1 by n into n power m. Okay. Now we have to further simplify this. How can we simplify? N factorial by n minus x factorial into x factorial I will write outside. Then inside whatever is left over we will write m by n into m minus 1 by n minus n then m minus 2 by n, so on up to m by n minus, see, wait a minute, here you have by separately, then here also by separately. This is m by n and minus 2 by n. The same way m by n minus x minus 1 by n into, this is one term, then the second term is 1 minus m by n into 1 minus m by n minus 1 by n, so on up to 1 minus m by n minus n minus x minus 1 by n by n by n into 1 minus 1 by n, so on up to 1 minus n minus 1 by n. Now what we will do? We substitute n tends to infinity. And m by n we tend to p. So wherever you have n, you take infinity, and wherever you have m by n, you take p. So that is, this is nothing but NCR formula, no? So we can write this as nx in brackets. This is the representation of NCR. Then p into p minus 0 into p minus 0, like that you will get x times in the first bracket. And in the second bracket, 1 minus p into 1 minus p minus 0. See, if n tends to infinity, 1 by n tends to 0. That's why wherever we have 1 by n, we are writing 0. Understood? So on up to n minus x times by 1 minus 0 into 1 minus 0. So finally, what do you get? That is NCX p power x into 1 minus p power n minus x. That is NCX p power x. 1 minus p is q, because p is success and q is failure. So 1 minus success will become failure. That is n minus x. Now, finally, we have to conclude. Since the probability mass function of binomial distribution is obtained, so it can be concluded that binomial distribution is the limiting case of hypergeometric distribution. Understood?